Welcome to Algebra 2. Today we're going to be discussing solving logarithm functions and inequalities. Now, to solve these, many times all we need to do is to rewrite it in its exponential form, and then we'll be able to solve it correctly. We do want to just keep in mind this one tidbit of information though. If we have log base b of x is greater than y, that means that x is greater than b to the y. So notice where the x is, if the x is on the left, the x stays on the left. Okay? The other way how we could write this is that if we have log base b of x is less than y, then we have 0 is less than x is less than b to the y. We need to make sure that we include this 0 here because we cannot have negative logarithms. If you recall the graph looked like this, and we never have any values over here, so we can't have any negative values. That's why that 0 is there. So we're only going to need to pay attention to that if we are less than our y, then we need to make sure we take in consideration that as well. So now we're going to go ahead and solve these by rewriting them in exponential form and then solving that exponent. So here we have log base 8 of n is equal to 4/3. So we know that this would be n is equal to 8 to the 4/3. Now if you recall our rational exponents, the number in the denominator is the root that we are taking. So this is the same as saying the cubed root of 8 to the 4th. Well, the cubed root of 8 is 2, so 2 to the 4th we know is 16, so n here equals 16. Okay, second one, we're going to rewrite it. So keeping in mind what we just talked about, x is on the left, x has to stay on the left, so we'll have x, and it's greater than, so we don't have to worry about the 0 part of it. So x is greater than 6 to the 3rd, and 6 to the 3rd is 216, so x is greater than 216. Alright, we're going to do a couple more examples here. Here we have log base 4 of x squared is equal to log base 4 of 4x minus 3. Notice that in this case, these both have a log base 4. Since these both have a log base 4, our equation will just be what the insides are. Okay, so we don't have to rewrite this in exponent form. Instead, we're just going to say, well, if we're taking the log base 4 of these two things, and these two things must be equal. So x squared must equal 4x minus 3. Well, now to solve this, since we have an x squared and an x, we're going to move everything over to one side and get it equal to 0. So we will subtract our 4x and add our 3. So we have x squared minus 4x plus 3 equals 0, and then we can factor it. So this would factor to x minus 3 times x minus 1. If you think about this, our outside would give us negative 1x. This would be negative 3x. And negative 1x minus 3x certainly gave us our negative 4x. So it works. So now we just solve each of these for 0. So x minus 3 equals 0 tells us that x has to equal 3. X minus 1 equals 0 tells us that x has to equal 1. And we do want to take these two values and double check that they give us positive values inside these logarithms, because if they're negative, they just don't work. So 3 squared is positive 9, so that works there. 4 times 3 is 12, minus 3 is 9, so that works. 1 squared is 1, and then 4 times 1 is 4, minus 3 is 1. So both of these work, so our solution here would be 1 and 3. Alright, so let's look at the second example here. So for the second example, we have log base 7 of 2x plus 8 is greater than log base 7 of x plus 5. So since these both have a log base 7, we can just make our equation out of the insides. So 2x plus 8 should be greater than x plus 5. and solve it. So we'll subtract x from both sides and subtract 8 from both sides. So we have x is greater than negative 3. And we want to check this to make sure that the values that we plug in here, we won't end up with negative values. So here, if we have negative 3, be negative 6 plus 8 is a positive 2, so anything greater than negative 3 would certainly be positive there. And here, negative 3 plus 5 is 2. It's positive, so anything greater than negative 3 would be positive there as well. So x is greater than negative 3. So that is how we solve logarithm functions and inequalities.